Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Dr. Brad Tucker is here. Brad, it's Tuesday.
How's it going?
Really well, my friend. Let's get the headlines in this 41st week of 2021. First potential exoplanet to orbit 3 stars, a trinary star system, if you will, has been found. Lucy's mission to a half dozen asteroids set for launch this weekend. And it appears that Pluto's atmosphere is disappearing.
This is Trekzone's Talkin Science. And you can get exclusive behind-the-scenes info and first-play access to all Trekzone podcasts by becoming a member today. Click join on every Trekzone video on YouTube. Go to the trek.zone/support or scan the QR code on screen throughout the show. Now, it's back to you, Matt.
Well, thank you very much, Ross. And a quick mention of our socials: Trekzone's on YouTube, Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow, and subscribe. Leave comments and ratings. That'll help us convince the algorithm we're worth it. Brad, too, on social media, at btucker22 on Twitter, Dr. Brad Tucker on Facebook. Brad, a Canberra-based company is proposing a manufacturing hub in New South Wales to enable Aussie-built satellites up to 500 kilos. This is an interesting prospect.
Electro-Optic Systems, a friend of us here at Mount Stromlo, who's been in the satellite game for a while, looking at just kind of over the border in Queanbeyan, kind of on a essentially suburb of Canberra, to start manufacturing some larger satellites that us and a lot of other people be involved with. And it's another sign just of how quickly this whole thing is moving as an industry in Australia, with companies and research organizations and groups all supporting each other to build the bigger and best next thing.
Yeah, absolutely. Looking forward to that one. Well, first up in our headlines, a weather delay has nixed Blue Origin's planned launch today. They're going to try again Thursday, our time, Brad.
Yeah, a little bit of a delay through some high winds. Not surprising. I mean, these things happen. Florida has this all the time. So Captain Kirk will just have to wait an extra day before boldly going where he's talked about going before.
China's announced their intention to kick off space tourism flights from 2024, Brad. Competition from the unlikeliest of places.
Yeah, look, China's having a very rapid expansion in their program, as we've talked about, doing things on the moon, Mars missions, their space station. Not surprising they would get into this game. They've kind of seen that the game can be quite lucrative and promising, and clearly you expect there's a lot of interested parties from China. And, it also may just go to quell any potential issues, given that NASA does contract to SpaceX, Blue Origin. They may not be able to take Chinese nationals on board as per other U.S. policy. So this may prevent any future issues from all people, regardless of their citizen of origin, being able to go into space.
Well, some pretty awesome news to kick off our main act, Brad. The GWORI system has likely developed an exoplanet or two.
Yeah, so this is kind of a really cool one in the sense that we've detected lots of what we call circumbinary planets going around 2 stars, the Tatooines. And we have seen stars that exist in trinary systems, 3 stars. However, the planet appears to only go around one of those stars. So it's still just orbiting one star, but it still does have 3 stars in the system and 3 stars and suns in the sky. This would be the first where the planet is on the outside of all 3 stars and goes around all 3, just like we do around the sun. So it'd be a very interesting confirmation, if true, if this system really is what we think it is, and that is the first orbiting of a 3-star system.
Yeah, and astronomers have spotted the protoplanetary disk, if you will. There's 2 of them, in fact, an inner and an outer disk. And the suggestions are that a massive planet, or even planets, is separating those 2 disks and rotating and coalescing into planets. This is just incredible.
Yeah, it's a very cool, image from the Very Large Telescope in Chile, and the high resolution it can do is really starting to see the gaps in the disk where they think obviously planets are forming, and then realizing that these gaps in this disk are on the outside. It's not that we're not surprised it's happened. Planets they see something surprising in a good way, like every configuration of a planet, just seemingly we keep finding. It's good confirmation to find it again, if this really ends up being what it is, given it would be a very unique system, and there's a lot of work and study into binary and trinary star systems, and then obviously questions around their ability and how they host planets. Would it only be where it's hosting one? And could you ever get it? And then obviously the questions of how they all form and that sort of thing. And that's also what's unique here is you're still seeing the formation process take place, which is always great because you get to see what is happening in the physics of how the planet and these stars are forming, which is always a big question in any planetary system.
Yeah, absolutely. Now, as you alluded to, it is the first exoplanet to be orbiting three stars, but it's not the first found in a trinary system. LTT 1445AB. We've talked about naming conventions in the past. That's been found, but that one only orbits one of the stars in the trinary system. Orbiting all three is pretty incredible. I would have thought a little bit impossible, though, Brad.
Yeah, I mean, that is the unique thing that it's orbiting all three as opposed to just one. And look, it all has to do with how the stars and then the gas form. If you can get stars of similar size and similar age, well, this may be how you get one of these planets orbiting all three instead of having some formation of a star earlier before other stars or dramatically different in terms of its massive properties. We don't often see rarely evening stars, even stars rather, but they can happen. We do see them. We do know they exist, and so it's just another surprise, another piece in this. How do all these planets and stars come together? Which is just a very fundamental question. And as we start discovering all these different ranges and combinations of planets and stars, really teaching us about the whole picture. We would get a very biased picture if we just studied our solar system with one star and eight planets. But most of the stars in the nighttime sky in the galaxy are two or three or even more star systems, not just singular systems like our sun.
Now, this could dramatically increase the likelihood of planet formation if correct, Brad, with planets able to form anywhere the ingredients are, not just if the conditions we think are needed are right.
Exactly, and that's the key here is updating and understanding those conditions, because if they can form at any part of a multi-star system, that definitely opens up the possibilities of just where and what they can be in terms of their numbers, how many and the sizes and that sort of thing. So definitely why it's can be quite an important discovery, an important solar system or star system to keep studying into the future, just because of clearly how unique it is, but maybe it's not unique after all.
Well, NASA's next asteroid bound mission to explore the earliest days of our solar system is gearing up for launch this weekend, Brad. Lucy is about to fly.
Yeah, Lucy has been obviously a big mission in the making, and it has a very long journey ahead, so to speak. But aiming to reach what we call Trojan asteroids. These are asteroids in the orbit of Jupiter, and study at least six of them, if not more, getting up close and personal. Obviously, asteroids are kind of all the rage lately. That's because these pipelines of missions are starting to finally come through, and you can go and reach and do these things to the asteroids and not just reach one target. It will go to multiple asteroids, as we said. So hopping from asteroid to asteroid and really putting a close eye on some of these objects we don't really have a good idea of yet.
Well, Lucy's named after the famous early humanoid skeleton that's been dated to around 3.2 million years, the discovery of which has been hailed as a keystone in understanding our evolution. The hope is the same will apply to the research gathered at these Trojan asteroids, Brad.
Yeah, because these Trojan asteroids, they are not in the main belt. We were just seeing, they precede and proceed Jupiter, and they're in a very stable resonant orbit there. And this has always been a fascinating area about these groups of asteroids, and clearly that they probably formed around the same time as Jupiter, but they just got stuck there. That obviously they could have been a minor planet, they could have been part of Jupiter, or Jupiter could have broke something, a lot of different possibilities, but they offer clear insight into the origins of the formation of the solar system, the ingredients, what was there, how they formed, all those sorts of things. And by looking at the stuff that didn't form the planets, you can get just as big as a clue as studying the planets themselves.
Well, Lucy will be visiting C, D, and P type asteroids. Now, C for chondrites and D and P for different types of low reflectivity asteroids, both of which may be rich in organics. The latter of which, those P types, we've never had samples of before, Brad. Certainly a groundbreaking mission.
Yeah, this is the sort of thing. I mean, we are limited in what we can tell about asteroids because we're just looking at the reflected sunlight. And if they're albedos, we say the reflectivity isn't strong. We don't get a good understanding or mapping of the elements or ingredients, let's say, what composites those asteroids. And so the fact that they are not reflective has always led us to believe they're organic. And the fact that we haven't seen one up close, with Hayabusa 2 and Osiris Rex, those had not visited anything like a P-type asteroid that we saw differently, which is obviously very important for then understanding exactly what those things are and if they are organic or organic compounds or just not giant chunks of metal, like a lot of the other asteroids, or the chondrites, clearly telling us about those ratios of elements in the early solar system was just a big gap in our knowledge that we need to do. And we think they hold the key, hence, as you said, the naming of Lucy.
Now, interestingly, Hayabusa 2 returned at the end of last year, and Osiris Rex is due back in the next year or two. Lucy, though, not a sample return mission. She's going to be looking at things and beaming back the data.
Yeah, it's one of those, you have to weigh up what you can do in terms of the sample returns and the visiting. And the fact that they wanted to go to Jupiter, keeping in mind it will take 6 years or so just to reach the actual area. This is a much further mission than Hayabusa 2 and Osiris Rex, which have total lifetimes of 5 to 6 years for launching, getting there, and returning. So it's not very easy to build that return mission in. So it's a lot easier to just build it to go out there and study them up close and personal. And then obviously, if your mission's going well, you can hop to more asteroids in the Trojan. Once you get there, it's a lot easier to hop between the asteroids, which is obviously their plan, as opposed to trying to kind of go back and forth, which would be quite tedious. And clearly, if they discover some amazing things, we may have a sample return mission out to Jupiter. But you have to kind of balance what your science goals are, and just because we've never visited these before, this was on the top of the list to visit as many as possible rather than just one.
Well, lastly this week, Brad, as if being stripped of planet status wasn't bad enough, yes, I'm still hung up about that. Now it seems Pluto's atmosphere is leaving it too.
Poor Pluto. Yeah, and it's not fully going away. It's just shrinking. It's getting quite cold out there on Pluto. And what they have noticed through measurements from New Horizons and with Hubble and that sort of thing is that essentially the atmosphere of Pluto is starting to condense or cool down, which as it starts to cool down, it's starting to, instead of being this nice puffed out, so to speak, atmosphere, it's starting to get closer and closer and colder to the planet. And this all has to do with that very slightly elliptical orbit that Pluto has, causing it at times to be closer to the sun and then at times further away from the sun. And with those dramatic changes in temperature, creates these, what we're finding out now, is to be very interesting effects.
Well, this new research has come about after Pluto transited past a star in 2018, from our perspective, of course. This gave researchers unique conditions to observe the icy planet, the icy world, with some backlighting going on to see what was actually happening relative to us, putting a light behind Pluto. Very key in this research as well. And as you say, from the New Horizons flypast in 2015, comparing that data to what they could gather in 2018.
Yeah, the occultations that they're called when they kind of cross in front of a star, as you said, that you kind of use this backlit to magnify almost, or to shine light on what's going on Pluto, and you can use that light to get detailed measurements. And again, it's much like we find with planets going in front of their stars. We're just using a different star to amplify the signal from Pluto, so to speak. So obviously, it's a really exciting thing to be able to see. And there's just still so much to go with Pluto. It was a big surprise of how um, strong, let's say, the atmosphere was. They found fog, they found all sorts of things with that New Horizons flyby in 2015. And now that gives us a baseline of measurements to see how it changes over time, given that we got so close and we knew a little bit more about what was going on Pluto. So it's, just shows how interesting the dynamics are, how the way the planet moves and interacts. It's still surprising us, so to speak, to 6 years after that fly by in July 2015.
Well, incredibly, Brad, now I've done it as well. Incredibly, Brad, the researchers had a 2-minute transit to make this observation, plus the data from New Horizons, as we've talked about. While occultation is a pretty common method of study, it's still an incredible one nonetheless, Brad.
Oh yeah, and you have to be literally, as you said, at the right place, the right time for that exact few minutes. It doesn't happen for very long. 2 minutes can be quite a long one. You really need to be the alignment perfectly, and even on Earth, you have to be in the right position. This is where some of the benefits, say, of Sophia, the infrared observatory, which flies in a Boeing 747, is because it can fly to the right spot. And they actually did this for one of the occultations of Pluto back in 2018, getting to that right spot to do this exact measurement, because you want the alignment to be spot on for as long as possible. Much like seeing a total solar eclipse. You could be near it, but if it's not passing in exactly the path that you are, you won't see that totality. You'll see 98% or 95%. So you want to maximize your chance. So it's a hard technique to do. And that's often why you don't do it, except when you have things like Pluto, which are already so hard to study and you're limited in your techniques. This is one worth trying, as opposed to, doing this on Jupiter doesn't really add much because it's really easy comparatively to observe Jupiter.
Well, just before we go, Brad, a look ahead to this week's when we continue Talkin Science. I'll be up early to update our mission, William Shatner's Blue Origins mission, William Shatner's incredible first flight past the Kármán line, and the second space tourism flight for the Jeff Bezos-led company. And members will have first play access to that interview, so be sure to sign up with the join button below this video on YouTube, or go to the trek.zone/support to get access for less than a cup of coffee per month. Brad, it's great to pick apart the stories of the week with you. We will do it all again next week.
Sounds good.